collisions. We love them, we hate them, but above all, we absolutely hate them. Today I'm going to explain how we went from making collisions that look like this to this. One key aspect of all first-person games is movement, especially in exploration, since that is what the player will do the most, the complexity of which can vary depending on how explorable and intricate the environments are or the player needs. In your newest project, Within Clay, it's no different. One thing we decided early on is that we wanted simple movies, so that means no jumping, no parkour, and nothing of the sorts.
Parkour!
Since our game focused on puzzles, mystery and exploration, there was no need for that complex type of movement. However, our artists still wanted to make fantastic and grandiose environments. Given our summer palace setting, this left them a lot of opportunities for them to go wild. And here's where we raise a very important issue. What happens when you have a game full of cliffs, ledges and holes that you don't want the player to fall into? Do you just respawn them in the nearest possible location? Do you let them die or fall into eternity? And you see the problem? None of these are actually a good solution or satisfying for the player. And so this is what led us to develop this system that places invisible player borders around the player that stop them from falling in places we don't want them to. This will be a more technical type of video, so if you like this type of content, be sure to leave a like and subscribe if you want to keep up the progress of our game. First things first, we needed to establish some requirements that our solution needed to achieve. Number one, he had to maintain the physics-based movement and could not worsen that experience in any possible way. Number two, it still needed to allow the player to fall in places we want them to, since the player will need to fall in certain places in order to progress in the game. And finally, number three, it needed to be scalable and easy to implement in our levels. In my first approach, I just used the Unity raycast system in order to check if there was ground ahead of the player. If there wasn't, I would then check if the player could make that fall, or if we needed to stop that movement in its entirety. And honestly, this first approach was very terrible, not only from the calculations that were stupidly hard to make, as it also failed the requirement number one of worsening the player movement experience. So after these two initial failures, I decided to go on into game study, and I was able to find the two most important Reddit posts of this system. In my game study, I found out that most devs create invisible player borders that stop the player from falling, and it was this exact type of solution that I found in these two Reddit posts. The first approach made by Reddit user iPhobo showed off his approach in making this solution. The post didn't have any code, but in the comments the dev shared this process and I was able to understand what they were doing. They were also a very clearly experienced dev as they had a lot of assets in the Unity store, including this one. With a little bit more research, I found the second post, made by Reddit user Outworld Developer. Like me, he also found the first post and was inspired to create his own solution. He shared his process and code in the comments and I was able to use this as a base. Here were the main changes that I made to the second post code. First of all, I created a player border prefab that I could instantiate through code. Not much to say here other than the fact that I created and set up a special debug layer that isn't rendered by the player camera and is just rendered in the editor. This was a very useful change as it still allows devs to see what the player borders were doing without worsening the experience of the player. I then created a dedicated player border component for my player prefab. The script itself stayed relatively the same to the second post, but I did add some small optimizations like an onDestroy function that ties the instance of the player borders to the player's instance. This basically just means that when a player is destroyed, the player border is also destroyed. I then moved the handle player border function into the fixed update, so that the player borders are updated at the same time as the physics-based movement. Also to this handle function, I added some small checks that just make sure this code only runs when it's necessary. Like when the player is moving, or when there is no ground beneath the player and the player is already falling. I also added and created some dev tools that we could use to debug and test this player component. This basically just draws the raycast rays in the editor so that we can see what is actually being checked and if it's properly checked. But the most important change that I made was between lines 149 and 154. This line icon determines the position of player borders when there is no ground ahead of them. Where in the original second post code the player borders position were being set in fixed intervals, I changed it to be using the collider closest point to bounce. In the comments of the first original post, there was a suggestion to use the physics closest point. This does basically the same as the collider closest point to bounce, but this one just guarantees I get the position exactly on the collider's bounce. So this what this allows me to do is that when there is no ground ahead, I will get the closest point to the ground collider and set the player border exactly on the ledge. And this was the most important change that I made, as since the original code set at the player border's position in fixed intervals, it caused some jittery movements in some types of movements. By making sure the player borders are placed exactly on the edge, this removed that jitteriness entirety. I also make sure to set the rotation of the player borders to be the same as the ground collider, as there were some degrees of movement where the jitteriness would occur. And voila, it works! And this solution not only meets all of our requirements, but is incredibly efficient. and it helped us save a lot of time that would have been spent placing invisible player borders throughout our game levels. Although it's still not perfect, it has two main issues right now. The first one is that the player borders get a bit confused when there are overlap ground colliders. When this occurs, the player borders get placed incorrectly and still allow the player to fall. I haven't found a solution for this one, so if you have any suggestion, please leave it in the comments. But right now, we just don't overlap surfaces and we roll with it. The second one is corners, specifically outward corners. The script gets a little confusing placing the player borders in these types of corners, and, as you can guess it, allow the player to still fall into. This doesn't occur very often, but it's still annoying that it does, so I'll need to fix it eventually. And that's all, folks. Thank you for watching this video, and if you have any suggestions how I could possibly fix these two problems, I would greatly appreciate it if you leave it in the comments. Also, you can also leave any optimizations I could add to my code. And if you like this type of video, be sure to leave a like and subscribe if you want to keep up with the progress of our game. Also, if you have any questions, you can leave it in the comments below, and I'll do my best to answer them. But if you fail to, you can also find the two original Reddit posts in the description of the video. Thanks for watching. Bye!